Okay, we're going to start our geometry unit, and we're going to look at something called scale drawings and scale factor. And there's going to be a lot of emphasis on proportions here. But before I do that, some of you had asked me for a math joke or just something to make the notes a little bit more interesting. So here's your joke. What should you do if you're standing in a room and you're cold? Stand in the corner because it's always 90 degrees. So now that we've gotten that kind of corny joke out of the way, let's talk about our scale drawings. So we're going to practice with some proportions before we get into it. We're going to look at our first one. P divided by 8 is equal to 13 over 2. So realize with proportions, remember we said that this proportion has to be equal or equivalent or similar to the second proportion here. So I'm saying P over 8 is similar to 13 over 2. Now, if you remember, we solve proportions by cross multiplying. So 2 times P is 2P, and 8 times 3, or 13 I should say, is 104. Okay, and I'm just solving this one-step equation. Dividing by 2, and P is equal to 52. So in other words, I would be saying 52 over 8 is the same as saying 13 over 2. They're equivalent fractions, they're equivalent ratios. Okay? Go ahead and pause here and try B on your own. See what you can come up with. Okay, so let's look at B. 11 over 10 is equal to R over 11. So 11 over 10 is equal to what over 11? So just like before, we'll cross multiply. I always like to start with my variable term. 10 times R is 10R equals 11 times 11 is 121. And so we'll divide through by 10 to get R by itself. And R is equal to 12.1. And finally, let's look at C. A over 10 is equal to 11 over 14. So what over 10 is equivalent to 11 over 14? Cross multiply your variable term and the number. So you have 14R equals 10 times 11, which is 110. And so we'll divide through by 14. And so R is equal to that really long number, but we'll go ahead and just round it to the nearest hundredths place. So 7.86. And that's all to solving a proportion. That's all we really need to focus on. So here's your essential question. What is scale? And what are scale drawings? Well, scale drawings are models that are used to represent objects that are too large or too small to be drawn or built at the actual size. So think of things like blueprints, model cars or model planes. If you've ever built something like that, that would be a scale, okay? And scale shows a relationship between two sets of measurements. So if you ever look at a map, you might have seen that maybe 1 centimeter equals 5 miles. That's a scale. So let's practice using scale here. The distance between, and I'm looking right over here at example D, the distance between Winter Garden and Daytona Beach on a map is 2.5 centimeters. So I pulled up a map, grabbed my ruler, measured the distance between the two cities, and it was 2.5 centimeters. Now we want to find the actual distance if 1.1 centimeters is equivalent to 26 miles in the real world. And we want to round this answer to the nearest hundredth. So we know one thing. We have one ratio here. 1.1 centimeters is equivalent to 26 miles. Now we're going to fill in this proportion with some information that we know and we don't know. We know that on the map, when I measured, the distance was 2.5 centimeters. What we're looking for is to find the actual distance. We don't know that, so I'm just going to put an X there. So right now we've created a proportion. I'm saying 1.1 centimeters to 26 miles is equivalent to 2.5 centimeters to X amount of miles. Notice that I kept all my centimeters across on the numerators and my miles on the denominators. So we'll go ahead and cross multiply. 1.1 times x, 1.1x. 26 times 2.5 is 65. And we'll divide through by 1.1. We get that really long number there, but we'll round it to the nearest hundredths place, and we'll say that x is equivalent to 59.09 miles. So almost 60 miles in between those two cities. I want you to try finding the length of question E, and I'll read it to you. A scale drawing of a rectangular room has a length of 6.2 inches and a width of 4.3 inches. The drawing uses a scale of 1 inch to 3 feet. So the first thing I want you to do is I want you to find the length, the actual length, and the actual width of that room. You can pause the video and try. Okay, so let's try that. Let's figure that out. So we know that the actual scale is 1 inch to 3 feet. We know that the length of this room on the scale drawing is 6.2 inches, and we don't know how many feet. So that's my proportion. I'm saying 1 inch to 3 feet is equivalent to 6.2 inches to X amount of feet. So we'll go through and cross multiply. 1 times X is X. 3 times 6.2 is 18.6. So the actual length of this room is 18.6 feet. Okay, now let's find the width of this room. So the same proportion stands, or a similar proportion I should say, 1 inch to 3 feet. And this scale drawing has a width of 4.3 inches and X amount of feet, because we don't know the actual length of that room. So we'll cross multiply. 1 times X is X, and 3 times 4.3 is 12.9. Now if we look at part I here, I is asking us how many square feet are in the room. Well, we know to find area of a rectangular figure, it's just length times width. So 18.6 times 12.9 gives us 239.94 feet squared. So that's our first part. Now we want to know how much will it cost to carpet a room if carpeting costs $5.50 per square foot. Well, if each square foot is $5.50, we have 239.94 square feet. We'll just multiply those two numbers. 239.94 times 5.5 gives us $1,319.67. So you're going to see that we can actually use a lot of different things when we're talking about scale drawing. We're going to talk about area, we're going to talk about money, and we're actually going to talk about percentages a little bit as well. So let's start talking about scale factor. Scale factor is a scale with the dimensions, or I should say same dimensions in simplest form. A reduction has a scale factor less than 1. And an enlargement has a scale factor larger than 1. So these are pretty easy, but let's go ahead and practice finding scale factor. Look at F. 1 inch to 6 feet. So when we look at a scale factor, we want everything to be in the same dimensions. So we can't have inches to feet. We have to have inches to inches or feet to feet. Now in this case, it's going to be a lot easier to convert that feet into inches. Okay? If we try to convert that inches into feet, we're going to come up with a really small decimal here. So I know that there are 12 inches in a foot, so 12 times 6 gives me 72. So the scale factor here, 1 inch to 72 feet, could be written as 1 to 72, 1 over 72, or sometimes you'll see it like this, 1/72. And that is a number that is less than 1. So if I had something that was 1 inch to 6 feet, I'm saying my scale drawing would be a reduction. All right, let's look at G. 2 feet to 6 inches. I'm going to convert both of these into inches. So 2 feet is the same as 24 inches. So we have 24 to 6 now, but we want this to be in simplest form. Okay, so make sure it's written in simplest form. So that could be 4 to 1, or 4 to 1 written like that. Okay, so this would be an enlargement because we know that 4 over 1 is 4, and 4 is greater than 1. All right, and finally, try H on your own. Pause the video, try it, and we'll see what we come up with. All right, so we have 2 feet to 6 yards. I'm going to convert everything here into feet. So 2 feet to 6 yards, there are 3 feet in a yard, so 3 times 6 is 18 feet. And don't forget, we want this in simplest form. So 1 to 9, or 1 to 9 like that. Now this would be a reduction because 1 over 9 is less than 1. Okay. Now if you had gone the other way and you tried to convert into everything into yards, okay, well that's a little bit more tricky because you're either going to end up with a complex fraction or some decimals that you really don't want to deal with. So if we looked at H again, 2 feet to 6 yards, and let's say I wanted it all in yards, well 2 feet is 2/3 of a yard because it's 2 feet out of 3 feet. So that would look something like this, 2/3 over 6, which is a complex fraction that we'd want to simplify. We'd want to divide that. 2/3 divided by 6 over 1. It's the same as saying 2/3 times 1 over 6. We now have a answer of 2 over 18, or 1/9. So we actually come right back to where we would have been, but we're doing a lot more work to get there. Okay, so just be very cognizant of what you want to convert your units into. If you have something that is larger, say a yard is larger than a foot, try to get those yards into feet, or like an F, we had inches and feet. Try to get those feet into inches instead of the inches into the feet, because we want to get something that's going to be a friendly number and something that is going to help us find the appropriate scale easily and quickly. Let's look at a real-world example. A landscape designer drew a blueprint of a garden she is designing for a client, and that's right here. The length of each square on her current grid is 1 centimeter and represents a length of 10 feet in the actual garden. So one of these grids is 1 centimeter long, each one. and they represent 10 feet on the actual garden. So when I draw a scale drawing of something, I'm not going to go and take up the entire room with a giant poster board and redraw the garden like that. I'm going to scale it down. All right, so we want to redraw this. Maintaining the same actual garden dimensions, redraw the blueprint so that 1 centimeter represents a length of 5 feet in the actual garden. So I want you to think about this. Will the new drawing be smaller or larger than this drawing I have right here? So the drawing on the left is 1 centimeter to 10 feet. Will my new drawing that is 1 centimeter to 5 feet be larger or smaller? Think about that for a second. So let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have my side A to B is 10, and I know that's 100 feet really, because if each one of these is 10 feet, and I have 10 little centimeter grid lines here, that's going to be a total length of 100 feet. So let's start to redraw that over here. Well, I know one grid is going to be 5 feet. Okay. 2 grids is 10 feet. So you might have already realized that when I redraw this, it's going to be a larger drawing than my original drawing. The scale is essentially doubling, even though it looks like it might go in half because we're going from 10 feet to 5 feet. So this is now 10 feet. So we'll do another 2, 20, 30, 40, 50, 60, 70, 80, 90, and 100. 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so that is side AE. Okay, and let's look at FA. Well, this is 2 over here, which means it's going to be 4 over here. 1, 2, 3, 4. That's side FA. Let's look at side FE. 1, 2, 3, 4 centimeter grid lines, which means it's going to be 8 over here. 1, 2, 3, 4. DE is 2 grid lines over here on the left, which means it's going to be 4 over here. DC is 1, 2, 3, 4, 5, 6, which means it's going to be 12 on the right. 2, 4, 6, 8, 10, 12. And from here, we can just go ahead and finish up our drawing. So notice that the original drawing and my new drawing look similar. They are proportionally the same. It's not stretched out in a weird way. We don't have something like this. Okay, we've made sure that's not a proportional drawing. But the red over here, the larger red figure, is proportionally scaled. So when you finish drawing it, other than recounting like I did, just check to make sure, does it look similar? Does it look like it's a proportional drawing? And it probably is. To finish this assignment, I would like you to do real world example number 2 on your own. A scale drawing of a meeting hall is drawn on centimeter grid paper as shown. The scale is 1 centimeter to 3 centimeters. Each one of these represents 3 centimeters. Redraw the rectangle on centimeter grid paper. You can just redraw it right here using a scale of 1 centimeter to 6 centimeters. And then I want you to answer these 2 questions on the summary. When reproducing a scale drawing, how can you know if the image will be bigger or smaller than the original? And in the real world example number 1, how did the new scale change the length of each side in the figure in the blueprint? Come to class with questions and we'll go over this and talk about it more in depth over the next few days.